Hi guys. In this section, we are going to talk about your layered approach of your network, how your layered networks can be designed, and what are the key things which you can keep in your mind while designing. So basically, layering is a classical mechanism which can be used to reduce the complexity of a problem. Layering allows you to work with one level of complexity at a time, so you can segregate your network or your problems to different layers, so your problems will not interact with one another. Basically, a key characteristics for any solution is the ability to examine the system in several abstract pieces. So you can consider your whole system into a different small pieces. And more important thing is there should be a minimal reference to other pieces of a systems for troubleshooting and your design purposes. So your networks are basically layered in with the help of your OSI or TCP/IP model. If you are familiar with your TCP/IP and OSI is the basic foundation layer for your networks. So you should think in mind that when you are dealing with physical layer problems, you rarely consider your IP address or TCP parameters. You focus basically on your electrical and optical signaling and so on. At the same time, a key characteristics of an elegant design is the inability to divide the problems or breaking layering boundaries. So in today's biggest problem is like networking is, if we examine closely, is involves some interlayer interactions or carrying information across the layers. This is the biggest problem for the network designers. You need to understand that there should be a minimal interlayer interactions or carrying information across the layer, and if it's carrying, how it should be. Um, the same concepts apply to the network design and the network technologies. A layered network allows different problems to be isolated from one another and resolved within a smaller set of parameters. So in further sections, we'll see how we are going to implement some of the concepts of layering within a network design, including how layering hides information and separate your functionality. So let's move on the next topic, that is your hiding the information. Uh, Hiding information is critical to the success of any of your network design because your large complex networks, it contains too much of information that for any commonly available system it's difficult to process and react on a real-time basis, because you're not dealing with a small topology or a home lab kind of scenarios. In a real time you have lots and lots and lots of information which you need to deal with. So it's very important, you need to understand that in what all the places you can hide the information. The two types of informations can be hidden in a network. One is your topology information, other one is your reachability information. Let's move in depth of understanding these two information hiding topology information. The topology of a network is basically, you can consider any physical layout or the interconnection graph. It is just a physical connection of your devices which provides a path for your packets to travel. Each of the three types of your routing protocol, whether it is link state, distance vector, or path vector, treat the topology informations differently. You might be very much aware of, because you are listening to the design section, that how link state the calculates the or deals with the information, how distance vector deals, and how path vector deals. So link state protocol, basically, if we just, let me have a pen. um, but what basically, if you have three routers, router 1, router 2, router 3, and if you run, this is router A, router B, and router C. If you run a link state protocol on this, so it's like C will share its connected link information to router B will further share its connected and what C has advertised to A, so that each and every node will have a full visibility of the topology, and they, after that, they run a algorithm to calculate the best path. So your topology information in your link state is completely visible to each and every. You're not hiding the topology information basically in a link state protocol. Similarly, in your distance vector protocol, if you run a distance vector over it, so C will send the connected information to B with a cost attached to it. B will calculate its cost to its attached network, which C is having, and B will then send to A not the topology but a properly calculated metric to A regarding the C attached network. So this is how your information processed in your distance vector protocol. So basically, at each and every node, if you closely observe, you are hiding the topology information in a distance vector protocol. Similarly, in your path vector protocol, it advertises a set of hops through the network that the update has passed through. This does not represent a path to a destination necessarily, but rather a set of systems through which the path might pass. In path vector, it proves that the path advertised is a loop-free path. Path vector protocols do not rely on cost to determine a loop-free path to this destination. So these are the basically three ways where your link state distance vector protocols interact. So in your link state, every pair of routers receiving each other's flooded link state is called as a same flooding domain. So if this is your OSPF or ISIS, you have a single flooding domain where each and every nodes have a full view of information. So this is a single flooding domain. So every router in the same flooding domain must share the same view of the network topology for it to provide a consistent loop-free routing. Link state network almost never consists of a single flooding domain. You might have encountered that you have area just because you want to interrupt that flooding domain. The router at the edge of a flooding domain adds the total cost to reach to a reachable destination within the domain. So the border domain router is kind of, they are summarizing the information from the flooding domain. Do remember, it's not hiding the, well, the border routers. It's basically what they are doing is hiding the topology information from rest of the flooding domain. Um, in your distance vector protocol, it relies mainly on a geometrical proofs that the path with the lowest matrix cannot be looped. So in the path vector, each node that update passes through attaches a kind of a marker indicating that a node to the update. If a node in a network receives the same update with its own marker attached to it, it rejects the update. This is how your path vector really works. So these are the three routing protocols, how they are handling with hiding your topology information. So as you can see from examining the three types of routing protocol currently in use, all three topology information, all three hide at some point your topology information. Link state, hide topology information at the edge of a flooding domain. Distance vector, hide topology information at every hop. Path vector protocol, hide topology information through filtering and aggregation. Let's move on the next topic, that hiding of your reachability information. Reachability information hiding is very simple. It's not you are hiding some kind of reachability, it's basically your summarization or aggregations. So it's you I'm not going to explain what summarization and aggregation is. You are very much aware of all those things. So when you summarize, you are hiding more specific reachability information inside a less specific reachability information. So this is one of the another key aspects of hiding of information of with the help of summarization. Next thing is separate functionality. One of the two primary purposes behind a layered network design is to separate functionality. Network typically need to do this following steps: provide a place for a user and a service to attach, implement policy including marking packets of quality of service, performing admission control, implement security measures and all those things, aggregation of traffic and network topology informations, forwarding of traffic between major topological areas or sites within a network, or connect to the outside of networks or the internetworks. So if you attempt to solve all of these problems in one place, the network would likely to be very hard to troubleshoot and manage. You will mess up with that. That's why you need to address these kind of different applications or different kind of issues. These all things should be handled in a very layered approach. So we'll see in further design, further sections, that how this all these things can be handled, or can be handled with your network layer approach. So in this section, we have taken care of hiding of the information, reachability topology, and all those things. Layered approach, basically how your network layered approach gives why it's very important for your network design perspective. Thank you very much, and we'll meet up in the next section.